Welcome to Brunswick's GS Series Pin Setter Operation and Service Training Program. This series is designed to prepare you for the service, repair, and maintenance for the full line of GS Series pin setters, including the GS 92, 96, and 98. Various versions of the GS pin setter will be shown throughout these video programs. This is the first of a 4-program series which corresponds to the written manual for easy referencing. This tape will cover pin setter basics, an overview of the mechanical sub-assemblies, and pin setter cycles. Program number 2 covers switches, solenoids, electronic assemblies, diagnostics, and troubleshooting. Program number 3 contains short explanations of the adjustments on GS Series pin setters. Program number 4, which completes this series, will cover preventive maintenance. 7 mechanical sub-assemblies and various electronic sub-assemblies make up GS Series pin setters. The ball pit, the ball accelerator, the pin elevator, the distributor, the setting table, the sweep wagon, and the drive frame. Whenever any position or motion is described in this tape or in the manual, it will be described as if you were a bowler looking at the pin setter from the foul line. All references of clockwise, counterclockwise, right, left, forward, or rearward will originate from this viewpoint. Before getting into the details of the sub-assemblies, we need to cover a few very important safety instructions. Pin setter maintenance should only be performed by properly trained personnel. Only correct tools should be used for the job and must be removed before turning the machine back on. Always wear proper clothing and non-slip shoes while working on the pin setter. Toxic or poisonous cleaners should never be used. Always have fire extinguishers available and store oily rags in a fireproof container. Care should always be taken while you are in front of the pin setter so you don't accidentally trigger the photocell that lowers the sweep. Before doing any work, the power must be turned off first. On pin setters with a universal electronic system, turn the high voltage box switch to the off position. If more than one person is working on the pin setter, turn both the front and rear high voltage switches off. If you are working on both pin setters of a lane pair with universal electronics, always turn off the power at the universal common box and remove the cable from the common box. On pin setters with a consolidated electronic system, turn the stop-run switch to the stop position. If more than one person is working on the pin setter, turn both the front and rear high voltage switches off. If you are working on both pin setters with consolidated electronics, always turn off the main power at the consolidated high voltage box and disconnect the incoming 3-phase power. Always lower the sweep board when you're working on the pin setter or the ball accelerator. Use a jack stand or other suitable support when you're working under the setting table. Always remember to reinstall all the machine guards and the ladder after your work is completed. All persons should be clear of the machine before restarting. Now that we've covered safety, we will review the 7 mechanical sub-assemblies. Starting with the ball pit area, you'll find a ball cushion assembly that absorbs the impact when struck by a bowling ball. The heavy rubber pit curtain, which stops the rearward movement of the pins and allows them to fall onto the transport band. And finally, the transport band assembly, which consists of a large band moving on 2 rollers. It pulls the pins and ball rearward. There is a hydraulic shock absorber mounted to the frame assembly that helps absorb ball and pin impact. After impact, the cushion returns to its full forward position, guiding the ball into the ball accelerator. The ball accelerator is mounted between the 2 pin setters. It returns balls to the bowler from either lane. It's powered by a three-phase motor connected to the universal common box or consolidated high-voltage box. Entering from the transport band, the ball goes through a door and onto a track. A large, flat belt mounted on two driving drums propel the ball forward to the ball lift. The ball accelerator's door system has been designed to prevent two balls from entering at the same time. It will not allow pins to enter the ball door. The pin elevator receives pins from the transport band and then raises them up to the distributor in preparation for setting them on the lane. The elevator is equipped with 14 shovels that lift one pin per shovel. The shovels are moved by two parallel chains, which are belt-driven by the distributor motor. There are two pin feed deflectors at the bottom of the elevator that help the transport band guide the pins into the elevator. If a shovel picks up more than one pin, these deflectors will help knock the extra pin off while positioning the remaining pin in the middle of the shovel. Halfway up the right side of the elevator frame is an ejector that will wiggle each shovel to remove one of two pins on the same shovel. When the shovel nears the top of the elevator, the guide on the right side tips the shovel to allow the pin to roll out onto the pin guide wedges. The two pin guide wedges turn each pin so that they always go onto the round belt's bottom first. On GS92 pin setters, the round belts carry the pins over a pin guide wire. This wire switches the pin guide over, so the next pin is sent to the opposite center lane. On GS96 and later pin setters, as pins enter the shark switch, they contact the pin count switch mounted on the top of the elevator. The switch counts each pin as it rolls out of the pin shovel and lands on the pin guide wedges of the shark switch assembly. The switch information is used to determine which distributor lane the pin should enter to find an empty pin station. The shark fin is controlled by a red solenoid which, when energized, directs the pins into the appropriate distributor lane. It uses the pin count switch information to make its decision on which lane the pin is sent to. This feature reduces overflowing pins and speeds up the pin setter cycle time. The pin moves down the distributor lanes until it finds an empty pin station. There, the pin falls onto the pin station's retaining bow. This unlocks the ejector flap and allows any other pins to move onto the next available station. When the setting table is ready to receive the pin, the retaining bow will drop the pin as the pin holder's gripper engages the pin release lever. Any pins that do not find an empty pin station will return to the transport band through the overflow chute located at the end of each outside distributor lane. The pins are then recycled back through the elevator system. If no bowling activity occurs within 45 seconds, the system automatically shuts off the distributor motor. This saves energy and reduces unnecessary wear and tear on the pin setter. The setting table detects for standing pins after a ball has been rolled. It closes the spotting tongs to pick up any pins standing on the lane, or loads the pins from the distributor to set them on the lane for a new frame. It has 10 pin holders mounted on 4 swing shafts. They are latched into the horizontal position when the table is up loading pins and waiting for a ball, down detecting pins, or closing the spotting tongs. When the table goes all the way down, all 10 pin holders are rotated to a vertical position to set the new pins onto the lane surface. The pin holders have a pin detector plate on the bottom that is pushed upward by the top of a pin when the table is lowered during detection. The electronic system uses this information to determine what the pin setter must do next. A pair of pin grippers, which are solenoid controlled, will open during pin loading time and again when the table is downsetting pins on the lane. On GS96 and later pin setters, the 7 and 10 pin grippers will open to double load these positions. This feature reduces the cycle time and increases the efficiency of the pin setter. Over on the left side of the table is a square shaft and latch assembly. This latch is used to keep the pin holders horizontal when the pin holder is not up in the home position. When the table goes all the way down setting the new pins, the square shaft will be rotated by a stroke limiter solenoid, which releases the swing shaft latch. A large spring mounted on the front swing shaft then pulls the pin holders to their vertical position. After the pins have been set, a roller on the rear shaft will press against a table jam switch actuator arm. This overpowers the spring on the front swing shaft and rotates the pin holders back to their horizontal position. They will stay horizontal until the stroke limiter solenoid is energized again. Another square shaft, located on the right side of the table, uses a series of gears and tooth bracks to drive all 10 sets of spotting tongs closed, as the pins are being raised to clear deadwood from the lane. The shaft then turns the opposite direction to reopen the tongs, leaving the pins on the lane for the next ball. Located on each side of the setting table are table rack tubes. On the right-hand side, the tube has a chain that goes up and over a sprocket. The sprocket is mounted on the guide tower and connects to a crank arm bolted onto the main table shaft. The table motor uses these to raise and lower the table. The left-hand table rack tube has a T-stop on the top of it, which stops the setting table from being lowered when it comes in contact with a stroke limiter plate. This allows the setting table to be lowered only part way for detecting and respotting pins. The stroke limiter solenoid then pulls the plate out of the path of the T-stop when the table is lowered to set new pins. The two functions of the sweep wagon are to prevent pins from rolling forward and to clear the lane of unwanted pins. The sweep wagon is held up by the sweep release assembly, which uses a solenoid to force the swing lever rearward. A roller bearing on the bottom of the swing lever pulls away from the tipper control, dropping the sweep wagon. The lowering of the sweep is controlled by an attenuator and a hydraulic shock absorber. When the sweep is down, the motor turns the sweep shaft clockwise. This rotates the crank arms and turnbuckles to drive the shaft and arms rearward and forward. To keep the operation smooth, there are 3 guide rollers on each side of the assembly. When the sweep is fully forward, the sweep motor is shut off, and its internal brake holds the sweep in this position. The drive frame assembly consists of 3 motors. The front motor operates the distributor, transport band, and the elevator. The center motor runs the sweep, and the rear motor raises and lowers the table. Now, we will look at how GS Series pin setters respond to bowling activity, which is referred to as cycles. To begin a cycle, the following sequence of events must occur. The pin setter must be on and waiting for a ball. The ball detector sees a ball and sends a pulse to the pin setter CPU. The pin setter CPU must have a confirmation that the following conditions are in effect. The table is up, the sweep is up and forward, and the spotting tongs are fully open. The ball door solenoid locks the ball door for 3 seconds to prevent pins from entering the accelerator. The sweep release solenoid energizes to drop the sweep. The sweep wagon lowers completely to the guarding position. The table motor runs counterclockwise to start the cycle. A cycle is divided into 3 segments. First is the detection stroke, where the table is lowered to determine which pins have been knocked down. Next, the table is raised and the sweep clears the deadwood. And finally, the pin setter prepares for the next ball. There are 5 different first ball cycles and 3 second ball cycles that the pin setter can perform. Starting with the first ball cycles, during a strike cycle, the pin setter detects that all the pins were knocked down, sweeps away the deadwood, and sets 10 new pins. During a standing pin cycle, the pin setter picks up any pins left standing on the lane, clears the dead wood, and then sets them back down on the lane and waits for the second ball cycle. A short cycle will occur when the 7 or 10 pin was the only one knocked down, or a gutter ball was thrown. The pin setter will skip the sweep portion on the cycle to save time. It then waits for the second ball. An out-of-range cycle happens when a pin is pushed off of its normal position, but does not fall. It will not allow the table to lower to its normal detection height. When this occurs, the pin setter will stop and signal for the technician to remove any deadwood and restart the pin setter. When a first ball foul is detected by the beam on the foul line, the pin setter CPU ignores any pinfall, sweeps the deadwood, and sets 10 new pins for the second ball. There are 3 second ball cycles. During the second ball cycle, the GS pin setter has the capability to generate scoring information internally or use an external scoring device. If using an external scoring device, the pin setter will use a single detect cycle, which stops the setting table from being lowered. It will then sweep and set 10 new pins to get ready for the next bowler. The pin setter will use a double detect cycle when it provides its own pinfall information. For scoring on Bowler Vision, AS90, ASK, or Framework's automatic scorers. In this cycle, the table lowers to detect. The sweep clears the pins, and then 10 new pins are set. A second ball out of range occurs when a pin has been moved off spot. This cycle is only active on pin setters that are configured to use the double detect feature. The pin setter must be reset by the mechanic or technician. It will then sweep and set 10 new pins to get ready for the next bowler. This completes this tape and the first part of your training. Please use your manual to review any operations that were unclear. The second part of your training is on program number 2. It contains information you will need to know about the electrical and electronic aspects of GS series pin setters. This program, the second in this series, will cover the electrical switches, solenoids, and motors found on GS series pin setters. The GS92, GS96, and GS98 pin setters have a number of switches to monitor, protect, and control the pin setter. Starting with the switch cluster located on the right frame of the pin setter, you'll find switches A through D. Their primary functions are to inform the pin setter CPU of the position of the setting table. The A micro switch is held closed by an actuator when the table is up in the home position. As the table lowers and raises, a small magnet mounted on a cam will close the contacts on the B, C, and D switches. The cam and actuator are designed to activate the switches either clockwise or counterclockwise. An elevator control switch is located on the left rear frame of the elevator. The rollers on the pin shovel shaft pulse this switch as they pass by. It must be pulsed at least once every 6 seconds, or it will stop the pin setter operation. Located on the front left side of the pin setter is the G switch, which is closed by the attenuator when the sweep is down in the guarding position. This must be actuated before the table can be lowered. There are 3 switches located in the mechanic's rear control box. The first is the set switch. It causes the table to lower onto the pins and detects, sweeps, and resets an identical combination of pins. This is helpful when service is required when a combination must be saved. Pushing the reset switch causes the pin setter to cycle to the next ball. On the bottom is a high voltage stop switch. This on-off toggle switch gives the mechanic the ability to shut off the pin setter from the rear. The out-of-range switch can be found on the right-hand guide tower. It informs the pin setter CPU if the table is lowered to its proper detecting height. If it cannot, the pin setter will stop. You must now turn off the pin setter, clear any fallen pins on the pin deck, and turn it back on to resume operation. Each pin setter has 10 pin holders in the setting table. On GS92 and earlier pin setters, each pin holder has 1 switch, which serves 2 purposes. First, during detection, the switch is activated when the pin detector plate is pushed up by a pin. Second, it will be activated when a pin is loaded from the pin station into the pin holder. On GS96 and later pin setters, each pin holder has 2 switches. One detects the pins during the detection stroke, and the other lets the pin setter CPU know when a pin has been loaded. This allows the pin setter to make a detection with a pin in the pin holder. This upgrade allows the 7 and 10 pin to be double loaded and all 10 pins to preload during predetermined times in a pin setter cycle. The spotting tong switch is located on the right side of the setting table and lets the pin setter CPU know if the tongs are open or closed. The small cam on the toothed rack will close the switch when the tongs are open. Mounted on the right side of the pin setter is the sweep motor switch. It will close when the sweep wagon is forward. Activating this switch turns the sweep motor off and causes the brake to stop the sweep before lowering the table. The table safety switch, TS1, is located on the back left side of the pin setter frame. It is a jam switch, activated only when the pin holders are unable to return to the horizontal position after setting new pins. A roller on the rear swing shaft of the setting table must overpower a spring tension actuator arm to close this switch. When this switch is closed, the pin setter will stop immediately. It will not restart until the problem is corrected. When the TS1 jam switch is activated, you should be aware that the table motor will reverse direction and lower the setting table until the C switch is closed. The pin setter will then stop for a mechanic's assistance. The TS2 switch is mounted on the top of the table guide tower. If the table is unable to return to its home position, it will activate this switch while the table motor is still trying to raise the table. The chain pulls the sprocket and shaft down and overpowers the tension spring, causing the TS2 switch to shut off the pin setter immediately. If your pin setter has the updated software, the table motor will reverse direction and lower the setting table until the C switch is closed. The pin setter will then stop for a mechanic's assistance. The pin count switch will be found on pin setters with a Smart Shark assembly. When pulsed, the switch will send a signal to the pin setter CPU. The CPU then energizes the shark solenoid, which positions the shark fin. The position of the shark fin directs the pin into the left or right distribution lane. Now, we'll examine the two types of solenoids used on GS series pin setters. The first is an intermittent duty type that is colored black. The second is the red solenoid that is continuous duty and capable of being energized for up to 90 seconds. A ball door solenoid locks the ball door for 3 seconds when a ball is detected. This will prevent pins from entering the ball accelerator. When a ball is detected or someone presses the set or reset button, the sweep release solenoid is energized. This lowers the sweep wagon. The purpose of the stroke limiter solenoid is to briefly pull the stroke limiter plate rearward. This lets the T-stop clear the stroke limiter plate, allowing the table to lower fully. The swing shaft latch is also released, allowing the pin holders to go vertical while the table is lowering. When activated, the spotting tong solenoid engages a gear clutch assembly. This causes the table drive gear to close or reopen the tongs. This movement will depend on which direction the table motor is turning. 10 red pin holder solenoids open the grippers on the pin holders while pins are being loaded or released onto the lane. On GS96 and later pin setters, the shark solenoid is used to control the shark fin guide. When the solenoid is energized, it directs the pins into the appropriate distributor lane. A universal electronic control system controls and operates the GS92 and GS96 pin setters. Consisting of several control boxes mounted on the front of the pin setter, the system is capable of working with all voltage systems throughout the world. Mounted on the front of each pair of pin setters, you will find a high voltage box. On the left pin setter, there will also be a game setter box and a common box. The common box is the entry point for the three-phase power. The common box distributes three-phase power to both high voltage boxes for the pin setters and the ball accelerator. A step-down transformer inside the common box supplies several low voltages to the printed circuit board. Also mounted in the common box, the ball accelerator contactor controls the three-phase power to the accelerator motor. Please refer to your manual for a detailed explanation of how the common box is configured. The high voltage box takes the three-phase power from the common box and uses it to operate the distributor, sweep and table motors, the pin light, the pin setter solenoids, and the masking unit lamps. The universal game setter box, which receives all its switch information through the high voltage box, is the central control unit for a pair of pin setters. It accepts and reads all incoming information from the switches, ball detectors, foul units, and the player control station for each pin setter. It then directs the motors, solenoids, and relays to perform certain functions at specific times. A detailed description of all its functions is located in your manual. The GS98 pin setter is controlled and operated by a consolidated electronic control system. This system consists of two control boxes mounted on the front of the left pin setter. On the bottom is the high voltage box. On the top is the low voltage box. The consolidated high voltage box receives the incoming three-phase power and makes it available for all motors, the pin lights, and 3 transformers, which supplies low voltage to the consolidated low voltage box. Refer to your manual for detailed operation. The consolidated low voltage box consists of 3 printed circuit boards, 2 I/O PCBs, 1 for each lane, and the CPU printed circuit board. This assembly is considered the brains of the pin setter. Each low-voltage I/O printed circuit board receives the incoming switch information and passes it to the CPU. The CPU then makes a decision and sends commands to the pin setter motors, solenoids, and relays through the I/O boards. The I/O boards also protect the pin setter solenoids and relays. Consult your manual for a detailed explanation of the I/O PCB. The CPU printed circuit board is the central processing unit or brains of the pin setter. It accepts all information from both I/O boards and processes it to determine what each pin setter must do. The CPU contains a microprocessor which makes the decisions and an EEPROM which the microprocessor communicates with to receive the operating procedures and rules. Consult your manual for a detailed explanation of the consolidated low-voltage box CPU. Two sets of switches are used to turn the pin setters on and off, as well as set and reset the pin setters. The key switch is used to enable the pin setter to diagnose pin setter problems. It can allow different pin combinations to be set and is used to return the pin setter to its normal 10-pin mode. One of the pin setter CPU's functions is detecting a ball rolling down the lane. The CPU receives its information from the ball detector, which uses a combination transmitter-receiver unit mounted on the ball return capping. This sends a beam across the lane to a retroreflector. When the beam is interrupted, a pulse is sent to the pin setter CPU. The foul detector works on a similar system which alerts the pin setter CPU when a bowler crosses the foul line. Several other switches are also involved with the electronics of GS series pin setters. The bowler's reset allows the bowler to cycle the pin setter to the next ball. The masking unit switch, located on the bottom of the masking unit, can be used to turn the pin setter off. The manager's control unit is located at the front desk of the bowling center and is capable of turning all pin setters on and off individually. Some GS pin setters feature a player control station. It has two basic functions, one to display pinfall information and the other to allow the bowler to select the pins they want to bowl against. The second feature is active if the pin setter is in the figures or figures clearing mode. Diagnostics and troubleshooting. The Universal Game Setter and Consolidated CPU have the ability to diagnose pin setter problems, shut down the pin setter, and turn on the trouble light. You can check the switches on the pin setter to verify they are working properly and that the wiring between the control boxes is correct. This is done by placing the pin setter into a contact closure diagnostic mode. Consult your manual for the procedure to start contact closure diagnostics. When an intermittent jam or failure has been reported, you can use the machine cycle diagnostic mode to put the pin setter into a continuous 10-pin bowling cycle. In this mode, the pin setter will set, reset, sweep, and reload pins until the problem can be identified. Please consult your manual for diagnostic mode procedures. When the pin setter stops and the trouble light is on, an LED display located on the top of the Universal Game Setter box or Consolidated Low Voltage box will show the error code that was detected. Review these error codes in your manual for future reference. In this tape, we've covered switches and solenoids, electronic assemblies, and diagnostics and troubleshooting. Please review this tape and become familiar with these sections in your manual so that service or maintenance can be performed correctly. This program in the series will provide a brief explanation of all the adjustments that can be made on the GS series pin setter, including the GS92, GS96, and GS98 pin setters. Before any adjustments are made, please review the safety procedures at the beginning of program number 1. Also, read the instructions in the manual carefully before beginning any adjustments. Before making any adjustments on a universal electronic system, turn off both the lane power switches on the left and right high voltage boxes. If you fail to do this, you or someone else may be seriously injured. On a consolidated electronic system, turn both stop-run switches on the top of the low voltage box to the stop position. The low voltage box is located on the front of the left pin setter. Once again, failure to do this may result in serious injury to you or someone else. The ball detector uses 3 adjustable spring-loaded screws to adjust the transmitter and receiver. This unit projects an infrared beam across the lane to a retroreflector on the opposite side. The beam is then reflected back to the receiver. When the beam is not being reflected, the red LED on the ball detector is turned on. This indicates that there is an object blocking the beam or there is an alignment problem. If there is no apparent blockage of the beam, then follow the alignment procedures in the manual. The transport band must be centered on the front and rear rollers and adjusted for proper tension. Refer to your service manual for this adjustment. The V-belt tensioner must be hand tightened as tight as possible. Then add 1 complete turn with a 17mm wrench. Also, check the transport bands and elevator's drive belt tension and make sure that they are the proper lengths. Please refer to your manual for a detailed explanation of these adjustments. The ball cushion must be adjusted so that the bottom edge is 10 to 15 millimeters in front of the ball protector ring and has 5 millimeters of side clearance. Proper adjustment of the ball cushion shock absorber is necessary to stop the ball properly and to prevent damage to the shock absorber itself. Adjust the ball door so it is centered in the ball door protector ring. There are 3 collars on the ball door shaft that should be adjusted as follows. The lower collar is adjusted to provide a 1 millimeter gap between the shaft's upper hitch pin and the ball accelerator frame. The middle collar should be raised or lowered to center the ball door in the protector ring. The distance between both A points and both B points should be equal. The upper collar needs to have a 1 millimeter gap between the door and the collar. The ball door lock allows the ball door to open only when the ball door solenoid is not energized. This is done when a ball presses the ball door key and clears the locking bolt by 5 millimeters. This is adjusted with 2 hex head screws that mount the locking bolt solenoid assembly onto the ball accelerator frame. The ball accelerator flat belt guard should be adjusted to operate properly. A vertical distance of 10 millimeters between the bottom of the guard and a ball riding on the ball track should be obtained. Under proper tension, the ball accelerator flat belt tension spring should measure 194 millimeters from center to center. Make this adjustment by tightening or loosening the 2 nuts that secure the long tension bar to the rear of the accelerator frame. Using the 3 adjustment points on the pin feed deflector, obtain a 6 millimeter clearance between the transport band and the deflectors. The elevator's shovel cam can be adjusted by rotating the elevator's pin shovels so the lower surface of a pin shovel is 22 millimeters above the surface of the pin turn wedges. Then loosen the attaching hardware and position the center line of the shovel cam on the center of the pin shovel's guide roller. Hand tighten the elevator drive belt tensioner. Then, with a 17mm wrench, tighten the adjusting nut an additional complete turn, 360 degrees. The pin count switch must be adjusted to make sure that all pins leaving the elevator are counted. This ensures that the distributor is loaded as efficiently as possible. To position the original style switch, an imaginary line is drawn between the tips of the deflector wings on the pin guide assembly. Position the switch so that its actuator is 35mm away from this line. Then, adjust the actuator height so that it is 75 to 80mm above the top of the wedge. The bottom of the actuator on this version of the pin count switch only needs to be positioned 20mm away from the imaginary line and 70 to 75mm above the top of the wedge. Please refer to the service manual for further details. The shark drive gear and spur gear must mesh properly to carry the pins from the elevator to the distributor. To adjust for proper gap, loosen the mounting hardware for the shark switch mounting plate and position the gear to get a 1 to 3mm tooth gap and retighten the hardware. To assure proper placement of the pins into the shark switch assembly, you must make sure that the upper rear corner of each pin turn wedge is 135mm from the rear of the elevator plate. To do this, simply loosen the pin turn wedge mounting hardware and position the wedge to 135mm, then retighten the hardware. Adjust the pin overflow socks so that the openings face each other. This will prevent excessive wear on the pins and transport band. For proper pin loading to occur, the setting table must be level. To do this, lower the table to the pin setting position. Measure the height of the table at the 1, 7, and 10 pin cutouts. If there is more than 3mm difference between each, then refer to the manual for adjustment instructions. The setting table must be adjusted in the at-home position. This is to assure that the table reaches the proper position for the A, B, C, and D switches at the correct time. This also allows the pins to be loaded into the pin holders no matter which direction the motor turned last. Note that the table must always stop at the same height when the A switch is activated. An adjustment is necessary if the relationship of the chain and crank arm are not equal when checking angle A and angle B. After angle A and angle B are equal, the table's height can be adjusted if necessary. There are two places that require proper adjustment of the table height to ensure the correct operation of the pin setter table. The first is when the table is in its highest position. The grippers on the pin holders should be parallel to the inside corner of the pin release lever. The second place to check adjustment is when the table is in its lowest position. When the table is lowered fully to set new pins, there should be 15mm plus or minus 5mm between the lane surface and the bottom of the table. Please reference the service manual for the proper procedure. With the setting table in its correct home position, the pin release adjustment is done by measuring the clearance between the inside corner of the pin release lever and the closed gripper. There should be approximately 7mm between the release lever and the gripper. Non-universal pin stations have a two-piece release lever. To adjust, loosen, and then position the center metal brackets so that the lever is at the correct distance. On universal pin stations, the adjustment is made by moving the individual pin station to obtain a 7mm gap between the release lever and the gripper. Another adjustment to the universal pin station ensures that pins will be released to the pin holders at the proper time. Adjust the end of the release lever so that 5mm is showing above. Refer to the service manual for a detailed explanation. If any pins are not spotted correctly, you can adjust the pin holders individually or in rows using the adjustment described in the manual. With the pin holder in the vertical position, check the pin detector plate's vertical clearance by measuring the gap between the plate and the stop bow. This gap should be 5 to 10 millimeters on all 10 pin holders. If it is not, carefully bend the stop bow to the proper gap. On GS92 and earlier pin setters, the horizontal plate adjustment is checked while the table is raised with the pin holders in their horizontal position. If any plate is not level, gently bend it until it is. To adjust the front to back position, you should bend the back tab on the plate's left support bracket to achieve a 3-degree tilt, so the front edge of the plate is 3 degrees lower than the back edge. Check the manual for details. The new style pin detector plate is found on all pin setters after the GS92 and is not adjustable. A 3-degree angle of tilt is built into the design. You must also adjust the detection height of the setting table, with the T-stop resting fully on the stroke limiter plate. A 10 millimeter clearance between the top of the pin and the pin detector plate is necessary. Your manual describes this process. The stroke limiter plate adjustment is checked by manually lowering the table until the stroke limiter T-stop barely touches the stroke limiter plate. There should be a 1 millimeter protrusion of the plate beyond the T-stop. This can be adjusted using the small bolt on the bottom of the limiter's vertical arm. Next, manually press the plunger of the limiter solenoid to check for a 5 millimeter clearance. This adjustment is done by loosening both solenoid mounting screws and positioning the solenoid properly. To check the pin holder switch adjustment, you need to have the pin holders empty and in their horizontal position. Check for a 3 millimeter clearance between the switch spring and the bottom switch finger. If adjustment is needed, carefully bend the rigid metal piece mounted with a switch spring. This style of pin detector plate is only found on GS92 and earlier pin setters. On GS96 and later pin setters, the pin detector plate has an adjusting bolt. The top of this bolt needs to be 12 millimeters away from the surface of the detector plate. Reference your service manual for a detailed description. If there is a problem with scoring, pinfall display, or closing of the tongs, then you must adjust the B switch. If the scoring or pinfall is a problem, loosen and move the B switch toward switch C. If the tongs are not working properly, then the B switch may need to be moved toward the A switch. On GS96 and later pin setters, adjusting the B switch may affect the double loading of the 7 and 10 pin. Please refer to your manual for further details. Holding the pin holders in the horizontal position is a latch hook mounted next to the rear swing shaft. Its release is adjusted by raising the table to its highest position and adjusting the horizontal stop bolt on the rear swing shaft to a 3 millimeter clearance. Now, manually bottom the plunger in the limiter solenoid, causing the latch hook to pull rearward and away from the latch bow, releasing the swing shafts. If a 3 millimeter clearance is not found, adjust the swing lever. If the spotting tongs are not picking up all the pins, the 2 adjustable stops located on the setting table's tong rack may need to be moved to allow complete opening and closing of the tongs. Make sure there are no damaged parts or obstructions interfering with normal movement. If the pin setter CPU senses an out of range when the table lowers to the proper height, the out of range switch needs to be checked. This is done by adjusting the cam on the right-hand table rack to activate the out of range switch as the table lowers. The sweep motor switch will inform the pin setter CPU when the sweep wagon is all the way forward with the crank arms and turnbuckles parallel. Adjust the sweep motor switch to the closed position. The switch's actuator should have some free play to avoid damaging the switch. Adjust accordingly. The sweep attenuator adjustment is performed when the sweep is all the way down in the guarding position. The attenuator rests against a stop screw, which should be between the frame and the front of the attenuator. Next, adjust the G switch so it has a small amount of free play while the switch is closed. This will prevent damage to the switch. The sweep wagon rides rearward and forward on guide rollers that are in two guide rails on the pin setter frame. The rollers must be adjusted so the mounting bolts have a minimum clearance of 5 millimeters from the inside wall of the side frame. Adjusting the sweep board height is accomplished by loosening the hex nuts on the bolt attaching the lift chain to the clevis. Raise or lower the bottom of the sweep board assembly to a height of 50 centimeters from the lane surface. While the sweep board is down and fully forward, adjust the gutter adapter to obtain no more than 5 millimeters of clearance. Check to see if the two distributor V-belts have 10 to 15 millimeters of free play and adjust them if necessary. Make sure that both drive motor chains have 5 to 8 millimeters of play and adjust if needed. Adjust the pin elevator chains to eliminate excessive free play. Refer to your service manual for detailed instructions. Check and set the B, C, and D switches for 3 millimeters of clearance between the switch and the magnet. On pin setters with universal electronics, check the 5-volt supply at the input to the game setter box. It must be set to exactly 5.14 volts and is adjusted in the common box. The 5-volt adjustment on pin setters with consolidated electronics is made at R145 on the low voltage CPU board. The reading is taken at J1 on the top of either of the two low voltage I/O boards. Connect the meter leads to pins 1 and 2 on the left side at the J1 connector. Adjust the pot at R145 until you obtain 5.14 volts. This completes an overview of the adjustments you will need when servicing the GS Series pin setter. Please review this program and the manual when you perform any of these adjustments, and always follow all safety procedures. Scheduled preventive maintenance is the modality of the center mechanic and his staff. In this program, we will discuss the proper way to service and maintain your GS Series pin setter. If correctly performed, scheduled preventive maintenance will decrease malfunctions, prevent major breakdowns, and lengthen the life of the pin setter. Scheduled maintenance should begin when your pin setters are new and should be performed on a regular basis. You must use a written schedule, such as these wall charts found in the back of your manual. This will prevent you and your staff from missing any important steps. This program will guide you through what should be done and how it should be done. Refer to your manual for a list of the various tools and materials needed to complete scheduled maintenance. Daily maintenance on the GS Series pin setter. Using your work schedule, first check the stop sheet for each pin setter. Copies of these forms are found in the back of your manual. It is important that all stops are recorded. The best way to accomplish this is to mount individual stop sheets on each pin setter to record the stop immediately. A stop sheet should also be used at the front desk. Once you've checked both stop sheets, you can decide what adjustments need to be done. The Shark Switch pin guide wedges must be cleaned every day with a general purpose cleaner. This prevents lane oil and dirt from building up on the surface and causing a pin jam. You should clean the pin wipes daily to reduce dirt from entering the machines. Just wash them in warm water, but don't use bleach or fabric softener. A daily check of the position of each transport band is needed. Make sure the band is centered on the rollers so it doesn't drift and start to fray. Every day, one pin setter should be completely cleaned. Not only does this allow you to keep up with your cleaning duties, but you will also have an opportunity to examine the entire machine for any loose parts or needed repairs. Clean one lane pair of pins each day to extend the life of the pins. Weekly schedule. Using a cloth or scrub mop and a general purpose cleaner, remove the oil and dirt on the transport band. Make sure to advance the band all the way around to completely clean it. Check all the V-belts for wear. Look for cracks, splits, or motor bounce. Wipe all the belts with a dry cloth while you inspect them. Be sure to look closely at the table motor drive belt. If this belt fails, it could cause the table to suddenly drop. This could severely damage the machine or cause personal injury. Make sure that the green belts are properly tensioned on the distributor, elevator, and transport band drives. If you find squealing, sagging, or slipping belts, they should be shortened or replaced. Examine the hydraulic shock absorbers for any sign of fluid leakage. Also, check the shock absorption on ball impact and the lowering of the sweep and table. Check the ball door shaft collars and split pins hitch pins to verify they are tight and holding the ball door in the correct position. Take a look at the overflow socks. If they are worn or misaligned, it can cause transport band and board damage. Correct any problems. Monthly maintenance. Using the general purpose cleaner, wipe off the dirt and oil accumulated on the front of the ball cushion and pit curtain. Check and tighten all the fastening screws on the ball cushion and transport band boards. Examine the setting table conduits for any damage from flying pins. Make sure the ball door locking mechanism is properly adjusted. The pin feed deflectors must be checked for proper clearance from the transport band and adjusted if necessary. Check the operation of the pin count switch and shark solenoid on a monthly basis. If an adjustment is necessary, refer to your service manual. The fluid levels of the hydraulic shock absorbers need to be checked on a monthly basis. Fill them to the rim while the shock shaft is in the relaxed position. Oil and grease all the items listed in the monthly lubrication schedule found in your manual. Vacuum the distributor's dustpan to remove any dirt or loose particles that have accumulated here. Remove and wash the overflow socks. Wash them with a basic laundry cleaner. Don't use bleach as it will weaken the stitches. Quarterly maintenance. On universal electronics, check the 5-volt adjustment at J5 on the universal game setter box and adjust at the common box if necessary. On consolidated electronics, check the 5-volt adjustment at J1 on the consolidated low-voltage I/O board. Adjust this at the CPU board if necessary. Clean the ball detector lens and reflectors with a glass cleaner that will not harm the plastic reflector. Make sure the guide rollers are moving freely. They should not be rubbing the side of the frames on the sweep tracks and sweep wagon guide. Also, remove any dirt or grease buildup and then reapply a fresh coat of grease. Look over the 4 table rack guide roller assemblies. At least 2 of the 3 rollers should be riding on the table rack tube, on both the upper and the lower side of each tube. Tighten and adjust if necessary. Check the tooth gap clearance between the table racks and the pinion gears. If there is not 1 to 3 millimeters of clearance in the raised and lowered positions, adjust them to the proper clearance. Examine the accelerator rails for signs of wear and replace any defective sections. Check the sweep wagon's gutter adapters for proper clearance. The overflow chutes should be checked for cracks or loose hardware. Carefully tighten all switch hardware while checking the adjustment and hardware connections for all function switches. The mounting hardware on all pin holders needs to be checked and tightened. Check and adjust the tension of both motor drive chains. Also, check the pin elevator's parallel drive chains. The distributor's bearings, shafts, and drive pulleys need to be examined for worn or loose parts. Tighten the mounting bolt and check the key for the table shaft's crank arm. Angles A and B on the table shaft's crank arm and chain need to be checked and adjusted if necessary. Lower the table onto a jack stand or suitable support. Remove the clevis and inspect it. Then, re-lubricate the crank arm shaft with grease and reinstall the clevis. Check the sweep release chain clevis for wear and oil it lightly. Lubricate all the items in the quarterly lubrication schedule located in the manual. Make sure the tooth gap between the shark drive and the spur gears is 1 to 3 millimeters. Check all shark switch adjustments. Semi-annual maintenance. The ball impact protection strips on the ball cushion board must be checked to make sure they are not loose or broken. If unchecked, this can interfere with the ball movement and cause damage to pins and balls. Inspect the ball cushion frame, stop collars, and bearings to ensure they are tight. The hardware on the kickback and accelerator box fiber plates must be checked and tightened if necessary to avoid pin and ball damage. Inspect the outer surface of the accelerator belt for cracking or wear. Then clean it with a cloth dampened with a general purpose cleaner. Check and clean the driving drums and discs. Accelerator motor suspension and the mounting shaft bushings need to be inspected to make sure the spring and V-belt are keeping the motor operating properly. The sweep release mechanism should be checked for wear, cracks, and proper operation. Check and tighten the fastening hardware on the sweep shaft bearing retainers. If the hardware is allowed to become loose, it can cause the sweep shaft to shift and the arms will hit the table. The sweep arm connecting rods and turnbuckles hardware should be inspected and tightened if needed. The clearance between the sweep track and guide rollers needs to be checked and properly adjusted. Inspect the plastic protector strips on the sweep wagon frame. Check the stroke limiter assembly for proper operation and adjustment. Make sure the stroke limiter lowers the table slowly during a detection stroke. Examine the pin holder swing shaft bushings to assure they are not worn or loose. Inspect the spotting tong tooth racks and gears for cracks which may prevent the racks from closing and opening properly. Clean them if necessary. Lubricate all the items listed in the semi-annual section of the lubrication schedule. Annual maintenance, though only done once per year, should be performed and documented just as consistently as all other maintenance. Tighten all the bolts on the pit curtain support brackets. Also, check the curtain mounting bolts. This will prolong the life of the pit curtain. Check and tighten the protector wedges and rings around the ball door. This will prevent ball jams and damage. Make sure the mounting hardware for the electronic boxes is tight and that the grounding straps are installed properly. Cabling should be inspected for any signs of wear. All the welding assemblies should be checked for any breakage. Re-weld or replace any cracked or broken parts to prevent extensive downtime later. Check all pivot and wear points for excessive play and tighten, adjust, or replace where it is necessary. Using your annual lubrication schedule, lubricate all the items listed. This completes the 4-part program for GS Series pin setters. Using these video programs, the service manual, and your expertise will keep your pin setters running smoothly for many years to come.